we are today with having a very quick look at this video privacy masking tool that I was messing around with as a bit of a joke, really. Since I was last looking at it, I've added support for multiple animations and some editing interfaces, that kind of stuff, and some preference support. To make it sort of into a little tool, it's not very impressive, but we'll have a quick run of it. The changes now is that you can pick your video that you want to work on, and it remembers that between runs. So we've picked this animation I was working on before, and it's just, the animation is just a folder full of bitmaps sequentially named. I think I could probably get this to use a secondary tool that will decompress a video into a series of frames, and then I could use that to work on, and then even get to recompress the frames on output, which would make it a lot more convenient to use. But at the moment you just grab your video and decompress it in something else, and then grab the frames and do that. Anyway, so this is just the video selection thing. You've all seen those things before. Here we can load animations, and they're stored in sort of a markup format. So we'll go to load Ava's animation. Ava is my dog there, by the way. These are the keyframes at the bottom. You can skip forward through the keyframes where we're tracking these keyframes, and between there it interpolates the position. Yeah, so we're not positioning every single frame, we're just kind of getting a rough position of each one. We could play that, but I'll quit out of that for a second. I'll load the socks animation. You can't add the titles at the moment. You can just do the editing. So now we're working on this animation here. This is our current position. Back to the start, and that's the socks frames there. So if I hit play, it would play Socks' animation. There's the stuff on screen there is just for debugging, actually. If I hit A, I can tell it to play all animations. Now you'll notice that Socks and Ava are actually being masked out. Struggling to pull this off the disk because we're loading raw bitmaps off my external USB drive. Once they're loaded the first time, it's actually much easier on the system to do that. The speed I don't care about, and if we're not doing the blurring or masking, if we're just having a sprite that's rotated to a particular, like a funny position or something, then that should be fine. Right. It just returns back to where we're editing from before. I think we've actually got one there for Sophie as well. I'll try that. I didn't bother to do the rest of her frames. There you go. But yeah, so if we look at this again, hit F5, and we'll go hit A for all. I have to go back to the start. From the opening sort of few frames, we'll see that Soph's being masked as well, because it's a different animation. So there we go. There you go. So the tool's very simple, nothing exciting really. We hit Q to quit and return back to the main menu. The menus are made with the text menu library I posted the other day, which is a bit of a joke really. Let's have a bit of a go over the code as it currently stands. It's probably over-engineered, and that tends to be the way I like to write these things. The editor itself exists within main, and the libraries we're using are includes we've already attached to the project. So we've got our menus library here, which is standalone pretty much. In other words, we can drop that into something else and just call the create function, and off we go. This handles menus in a different way. It's not unique, but it's a different way. I'll just have a look at, I'll find one of the menus in the main program here somewhere. This is our main loop. So we're creating a menu here. Get rid of some of the flack that doesn't need to be there. Or just move it down the bottom there. Things are commented out. So you can define a menu as a string, and then each option of the menu. At the moment, you don't even have to define a menu option as being anything. It's just each option is on its own row. It assumes that these are loaded from disk and created from a text editor, but here I've just created them in the code itself. So this select video option here has a particular setting. So if I click on this option with the mouse, it's going to call this function for us. And the animation editor, same situation, is going to call the function on click, and quit is going to call an exit here. The menu setup itself, we've got a phrasing option that runs through this text and decodes what these things are, creates a typed array really of all the options and what to do with them. Here I'm just colouring the background and just displaying the app title, putting the preview images on screen for the title page if there are any previews attached, putting the current path that we're working from, what video we're working from. We're updating the input state of the GUI, in this case the menu. So we're collecting information from the mouse and the keyboard, and then we're not reading from those things again. We've got a draw function to draw the menu, and then an action function to do stuff if you've interacted with the menu. So you can have a menu that has key bindings like this, the raw scan code. So if that's the arrow key there, I'll just drop that in here. If I had this one here, key binding 203, which I think is the left arrow. If I run this again, if I hit the left arrow, move the mouse away from here, hit the left arrow, it should jump to that menu. If you hit quit, I don't think quit's actually attached or anything in that menu. Hit Q to quit, is it attached, this one, or exit? It's not. Yeah, there's no key. Seeing quit here, there's no key binding, so if I press a key, it won't do anything. The actual call behavior is this little loop here. So we ask the menu what's been clicked, or what keys have been pressed, or what's been what the mouse was on top of. We get the string returned, which is just the name of the function or the action we want performed. So here I'm looking for a function with a prefix of GUI underscore, and if it exists, we call it. Pass control to that, we do whatever that does, and we return back to here. If it's not a function, it might be some other option we want to deal with in a manual way, like exit, for example. And that's how menus work. So the main application starts up with load preferences, create a default menu. When we jump to the secondary menu, I just open that up there, which is, I think, is that's the animation options there. We want to go to edit animation. Oh, that's an older one, sorry. It doesn't even need to be there anymore. Yeah, this is the animation menu. So we're building our menu in text yet again. We've got some key bindings on this menu, some click options here. We can have options where we don't display this at all, but we can tell it to trap certain key bindings. Handy. We can have other things. Yeah, if you wanted to go crazy with the menu stuff, you could have the font style as a property in here. The color, the highlighting, whatever you wanted to really. But I'll let that pretty empty in the menu itself. When we jump from the main menu to here, we push the state of the old menu to a stack to protect it, because we're going to come back to this menu at some point, at some later point. When we quit from this submenu, we create this new submenu, initialize it. The render loop is basically the same. You could probably standardize this loop and use call function to update or to call your own render properties within it, and just use the same menu operations as before. Here the processing loop on the internal processing loop from the menu is pretty much the same. We get a returned action from the menu library. We use the menu prefix and we call those actions. So in this menu here, we're dealing with creating animations, loading and saving them, that kind of stuff. So we don't actually, if I add new options to the menu, I don't need to have code in here that catches that option, calls the function, and comes back as one less little piece of that jigsaw I don't have to do. If we had more information in the menu about the display properties, like the size of the font, or what, even the font itself, or the colors, or whatever you want, the alignment, then you could do all kinds of crazy things, really, like setting a backdrop or whatever. So that's our menu sort of controls how we set up the application. And these are the very simple wrapper functions. In this case here, when we call load animation or save animation, we jump to this GUI here. And this is for dealing with the Windows dialogues, of course. We're checking to see if we have a current animation set. If we do, okay, we fall through. We get the file name that this animation had when it was loaded in, if it had one at all. We tell it to save it. There's nothing in here to do backups at the moment. So if you save something, it will overwrite something that already existed. I tend to like my own apps to dump old files as backups. Yeah, probably old-fashioned with that stuff. So let's have a look at this save animation and the animation library itself. Now, I've wrapped all of the animation and into sort of a basic library, really, which is what these functions here do. So I'm just asking it, does this animation we're about to save exist? And it's in a structure, it's in a typed array elsewhere. If it does, okay. Does the file exist? If it doesn't exist, we're allowed to write it. We don't have anything here for overwriting, now that I notice that. But anyway, so to make the animation itself, we're making a text file. So privacy animation is the title tag, getting the properties from it, creating these frames, adding them all, and then just dumping the whole thing to disk. Saving's pretty straightforward. If we go to the loading, right, so the loading's much the same. We've got basic file IO. We read the text file into a string. Once it's in memory, now we have to decode this thing. We'll look at the decoder function. We're checking to see if the document has anything in it. Maybe it's empty when you load the thing. Maybe it only has 5 characters, so it's probably not a valid document if it's empty, of course. Well, sorry, it can't be a valid document if it's empty. Once we load the thing in, we want to cut this text file up into rows. So we strip out character 13 and then we split on character 10. You can do it the other way around, makes no difference. Split character 10, character 13, who cares? So each line in the string array now has each line of text from that text file. We check our line count to do some just really rough verification. does this thing at least have 3 lines? If it doesn't, then it's probably not valid. We scan through the array and we look for this privacy tag, the first instance of it, and we look for the closing tag after that point there. So we find where the open and close tags are within this text document. So in theory, we can have multiple animations stored in one file. It doesn't support that at the moment, but to do that, we're just going to be looping the whole process. So we'll do this the first time. Once it's done the first time, it starts searching for the next animation after this point, if one existed. Do some quick checking to see if something dodgy happened. Is there a pair of valid tags in the file? If there is, cool. If there's not, we jump out and say, this thing's stuffed. I don't understand this thing. So this is the current privacy animation structure. We create one of these. It's going to hold all the properties that we're decoding from our file, and then at the end of the processing, we're going to determine is what we loaded valid or not. If it is, we add it to our privacy animation list. If it's not, we should pop an error and say, look, something's wrong with this, but we don't. It doesn't have any error tracking at all, I don't think. I think it has some error tracking for things like just printing stuff out to disk like that, but nothing to warn the user about that they've done something or something bad has happened. To phrase this thing, this text file, just have a look up here. See, just try and find give you an idea of how these files are laid out. They pretty much have these. I thought it was in there somewhere, but maybe it's not. So back to our loader. Once we've found where the privacy tag starts at the beginning of the document and the ending tag is, we can loop between those lines. We check if the line is empty, get the first character of the line, and all we care about is this thing, an alphabetical character. If it is, we're going to assume that this line has a key, it is in format of key equals value. So if it's a numerical alphabetical character, we're using the ranges here to determine if it is. Then we do a quick spot here. We go, okay, is that followed by an equals? So what we're expecting to see is a line of text that looks like this, key equals value. The key is the name of this particular bit of data, whatever it happens to be. Like it might be the screen size, it might be the last file you loaded, or whatever it happens to be. And this is the current state of it, whatever it happens to be. So if this was a color, for example, we might have, I don't know, screen color might be our key, and the color of it might be a hex value, or that would be a purple color. Moving on. If we find something that's after our key, if form equals, we step through, we grab the left fragment of it as the key, or in this case I've called it tag name it should be really, or the value. We look at this, do an uppercase of it to make sure we get matches in case the document's been edited and someone's added something by hand or whatever. If it's a name, then we assign this to our structure. We tell our structure, hey, I found the name of this object or this status or this particular item into our status. We need two things for a valid animation. We need a name of the animation and the keyframes. This thing does the property of the name, So we can add more properties into here. If I wanted to add more things, I would have a case statement in here. What was the one we just used? Screen color. Not that that's valid within this example, but if it finds something a screen color, it would assign that to whatever. And then we'd take the value and assign it to our property in here. So if the current animation had a thing called screen color, which it doesn't, but let's pretend it does, we would go, you know, the value, value of value, sorry. Because value is a string and we want to use it as a numeric piece of data, so we have to convert that using value. And the more of these fields we have, we just drop them into the same container. So there's a lot of setup code, a lot of sort of messing around to run through the document. It's not always needed, but you know. That's for a property. If we have a tag within our area, which is what this does here, it detects if we have one of these square bracketed tags. If we find one, we look for the end of the tag. Then we check if they make sense. If they make sense, we move down and go, can we find a close tag? So we scan ahead to find where this section ends, and then we work out what to do with it. We go, okay, let's look at the tag and let's see how this bit of code has to be interpreted. This bit of text has to be interpreted. In this case, it's doing a very similar thing. It's phrasing these keyframes, which is the animation aspect of it. We create an array. It's just an empty array. We start scanning these rows of text again. We're looking for these particular things. We want to know, is it a keyframe? If it's a keyframe, we grab the frame, the position, the size from it. It's a bit of work to do. But we can have nested documents. You can sort of, a lot of this is boilerplate. You could get rid of the boilerplate by messing around with it a bit. So our loading and saving, we're saving into a text format where we could really just use a binary format. I mean, who cares really? I mean, text is just convenient to look at, even though you can't really edit these things by hand. Well, you could, but yeah. That's the menu back there. So back to the library. Let's have a bit of a review of all the code. So it starts off with our regular constants. What this thing is, we use those constants throughout the program. So now I never refer to it, never enter this in anywhere. I just use the constant. We include the dialogues library, a function to check if the disk is writable, our string handle of an array. We're loading a text file into an array, which is something that this program does a bunch of times. Some graphics functions for drawing. There's one to draw the blurred circle, for example. Doing downsampling. You know, most of these functions will stand alone by themselves, so they're not necessarily related to what this program does. I just threw them together. Quite literally threw them together in many cases. The masking library here, and this is the main change that's happened to the program really. Originally the example would just let you have one animation. So, but we needed to have multiple animations to track multiple characters, and those we need to have within an animation. We need to actually have start points and end points. What frame it starts on, what frame it ends on. So we need to be able to handle all these multiple animations, and to do that I've set up this parent privacy animation structure. As you can see, it's very simple. We've got the name of this animation, its file name on disk, and a handle to the array of keyframes, or the mask keyframes in this case. The rest of this is boilerplate to let you call functions that deal with adding, creating privacy animation, just deleting one, finding the current one, etc. Just a bit of code that manages those things. So the rest of my program doesn't refer to these arrays or these type structures directly. It actually just calls these functions. Now I've separated the data from, very rarely do you need to do anything different than that, really. So these are all about the animations, and this is the, this is about skipping between animations, like choosing the next animation after the current one, moving to the next one, for example, moving to a previous one. All right, loading a privacy animation, which we just kind of picked over before. Oh, that's what the structure is. Sorry, yeah. I knew it was there somewhere. This is our document structure. So our privacy animation has an open tag and a closing tag of this document. We currently support a name field of this type. We have a nested array, and that array has these keyframe elements within them, and these keyframes have these properties here. So the keyframes are what frame we want to place our next step. So if we just run the application here for a second, go here, go new, thank you, hit edit. If I move the current frame to here, that's keyframe 1, and that's keyframe 2. So it's just saving those two keyframes. It's interpolating between the position between the two based on how many frames there are between them. But for those keyframes, we need to store things like its position on screen, its size, eventually its rotation, what kind of sprite are we meant to render. Do we want to blur the background? Do we want to have a pixelate or something like that? These are things I'll just drop in whenever I feel like dropping in, really. Because it's just a tool for me to make little animations with. Hit quit, get out of this thing. But this is how the documents are structured. We have these tags here represent an array of keyframes. We could just have them done another way, but it doesn't make any difference. For example, you could just have, I could have had these numbered. Have a prefix, and this could be up here. We could just go say, well, keyframe, and then like this, and then have that's the frame it's on, equals some number, position, using our example below there, and its size. Yeah, so we might be on frame 100, and we might have a position of 300 by 400, and it's a 50 pixel circle. Our decoder then will then run through and pick up. Okay, we found keyframe 0. We know what to do with these things here. We just have a bit of logic to pick them apart. You could do that. Makes no difference really. Just thought I'd try dropping it into that kind of structure there. That's our saving current thing, saving our privacy animation, and get back to here. So these are the keyframes themselves. Now, the way this works is that the library has a current animation we're working to, and once you create the animation, it creates a bunch of keyframes that are held in this stub array. And because they're held in this stub, we manage the handle for that. So if I dimension this mask array, I need to grab the handle and store it back in my current privacy animation. And when I change from my current privacy animation to a different one, I need to change those arrays. And that effectively gives us an array within an array structure. and we don't have to refer to the keyframes or the masks through the parent. So I can have this separate. So all I did was I wrote the library here with just the original dim statement, so I could only handle one series of keyframes, and then just substituted that for it, and now it can handle many different arrays of the same thing. The functions below it, they all act the same way. I think there might be a slight change. Well, there you go. When we creating the array and saving the handle, those things are a bit different, but the rest of it's basically the same stuff. Doesn't need a bit. Oh, that's why that's happening before. When you ran the program before, I noticed when you hit new, it created a animation 2 because that function was just sitting there in global scope being called. Oh, here we go. We found a bug. Cool. There you go. A bit of review of the code. Bit of some chit chat about how the thing works. I was messing around with doing the preferences stuff, and it's pretty horrifying if you don't really know PB, what's going on. The save preferences function is basically the same as the save. Here we're just creating a header like this for the text file, so it kind of stands out for what this thing is. Putting the date in the header when this thing is saved. We're dumping the current video properties, which in this case is just the path of the video we're working on, so it remembers that between runs. Eventually we'll have like a file history in here, and we'll dump all the files we've loaded or touched upon. We'll just dump them to the history, and we'll refer to those every time we reload the application. I kind of like that in my apps. I often forget where things are and so forth, and want to go back and look at some old program. Now that's the saving function. We just create this chunk of text and we just drop it to disk at the end here. Check, is the disk writable? If it is, we overwrite anything there and we just dump it to disk. Done. The loader is a bit more complicated, and I deliberately chose to mess around with the loader a bit. I'll go through it with you. It works basically the same as the other one, the loading of the animation. It loads the preference file, which is just a text file. In this case, I've wrapped that process up into an array. I pass it the array to dump the lines into, give it the file name, and it returns how many lines are in this thing. Pretty cool. There's some old code there. I was messing around with a different way of doing it. I've got an array here where I'm tagging what characters I don't care about. That if it sees these characters at the start of a line, just skip the line. No one cares. So in this preference document, the way this one's structured is that you kind of have to have you have like a comment, a comment line. Then you have like your key equals its value. That's the structure it accepts, it understands. But you also have like a section name as well. So you have like section name here, and then you'll have as many section names as what you want. So our file history will have its own section name, and then below that will be a list of files. File, and we might use these as like controls for how to restore this. Like this might be just called add file. That's the length, C/stuff. It'll just be the raw location of that file. Now to phrase this, to have it understand these sections, it has to run down through and find the section name. I'll just get rid of that, put that in a comment for now. It has to scan down the document, find the section name, and then decode these parameters that follow it with using this, whatever this is meant to do. And that's what this program does, is we scan down the document, we check our characters to make sure we've got a line we care about. If we find this section, this opening section tag, we look for the end of the section tag, and then we use our function calling ability to actually process this segment. So here I'm taking the tags, taking the brackets out of the function, the tag name, replacing any spaces that might be in it with underscores, adding this name here as our prefix to it, and then checking if this function exists. If it does exist, we can just jump. If it does exist, we call this function here, which decodes the following lines of text into this keys array, which gives us these the keys and values, and then we call our function, whatever it was named up here. So down here we actually have something that deals with. This is the function we're going to be calling. Oh, sorry, that's the key decoding list, because that job is commonly occurs. So we need to have that as like a function we just call to do this task for us, and then we process the results. So our load prefs in our current video, we just have this simple loop running through the tags that were found, looking to see if the tag exists, check the key, is it the path key? If it is, check to see if the value, the folder it is a valid folder. If it was, we store it in our editor preferences. So we can add new fields in here. Case, as we said before, like screen color would be something we could possibly catch. Then here we can have editor. If this field existed, this would work. What was it? To the value of tags loop dot value, because that's a string fragment in there, and that would be how we would decode that property from it. And when it's done, it just jumps down and calls the next. It just returns back to where it came from here and just continues this main loop, and it looks for the next section name. So think of it like we're reading from disk. We're searching ahead. Once we find a section, we decode all the values and properties that are stored after it. Once we're at the end of that, we go okay, and we just start looking for the next one. And we just keep doing that until we find we're at the end of the file. So this one's kind of over-engineered. It's more complicated than what I would normally write this stuff, yeah. But in a way, you could pretty much drop this block code here into a second include and just include that, and then call the load prefs and write your own decoders for these tags as they appear. So you wouldn't actually have to do anything special, if that makes sense. You're just writing to load your properties back. You're just writing these little fragments, or in this case, probably cutting and pasting them back together. Yeah, it was just another experiment. Anyway, that's way too much information about this application, which is just a junk application. Thanks for watching. I'll put the code up on the board. You can come and get it, etc. Mess around with it. And we'll see you next time. Bye.